Hi everyone, my name is Sabita Das. I am from Samram Institute of Technology, currently pursuing final year engineering in electronics and communication. Today, we are going to demonstrate a final year project that is GRIDIQ360 Smart Detection and Surveillance for Power System. So these are my teammates who were involved in our project. So these are going to introduce themselves.
Hi, my name is Shilpa K. I am currently pursuing 8th semester in Electronics and Communication Engineering.
Hi, my name is Harshita. I am currently pursuing my 8th semester in Electronics and Communication Engineering.
So now we are going to look upon the introduction part of the project. So as we know, in today's world, we are facing many problems related to power systems like power theft, insufficient electrical buildings, then malfunctioning due to the BESCOM people. So to eliminate these problems, so we are having our GRIDIQ 360, which will solve in real-time monitoring system. In this, our project comprises of four major units, that is smart metering, power theft, and line fault detection and overloading. So all this working part we are going to look upon one by one.
Hi, I'll be presenting my part of the project, which is based on smart metering. Smart metering is a new method of managing electricity. Unlike traditional meters, we just measure how much power we have used. Smart meters are prepaid, like a mobile recharge. Now I'll be demonstrating the working process of the project, that is smart metering. Now we'll use the app called Blynk app, where we can recharge. Now we are giving a recharge of rupees 100 rupees. Once the recharge is successful, the bulb turns on. As the unit increases, the amount gradually decreases from 100 to 90, 80 and so on. Once it reaches the minimum value of 20, the Blynk app receives a notification. Received a notification. It says the amount is low and please recharge. To sum up, smart metering is a modern, safe and efficient solution to manage electricity. It gives full control to the user, prevents wastage, saves time, money and avoids any third-party manipulation.
My part is focused on detecting electricity theft using a real-time monitoring and alert system. This system is designed to stimulate different conditions through 3 toggle switches states, which represents, I'll show in demonstration.
Now this is main line, means mains power supply, and this one main meter board representing the official ohm energy meter, and this one is internal home load like lights or appliances turning on or off. Now here's how it works. So now here's how the detection works. If the main line is on, the meter board is off and ohm load is on, it clearly indicates the power is being consumed without passing through the meter. This is a case is electricity theft. So I'll show now. The main is on. So now the main is on and this is the main, and the meter board, the current is not flowing through the meter board. So this is, I put it in the 0 condition, means it's off. And now I'm coming to this home. I'm considering this switch as a home. So now I'm on this. So now the power is in main switch and is directly going to the home, but it's not calculating in the meter board, means it's not going to the meter board. So this is where the electricity theft is detecting. Under this theft condition, the following actions are triggered. It is immediately sent to my Blynk app. I'll show how it will come. So notification I got as a theft detected, like 143, the time is 144, see. So I got with Google Map this one. So I got like theft is, see, again it's coming as, because I left like that only, so it's showing as theft is detected. So I'm getting notification. Where I can access is this, means I gave my email ID. So in email ID I can go, wait, I'll show. See, I got email ID. In this I can go to that Google map where it's detected. So whereas I'm in this, now I went to that location. So like this, the BESCOM people this project will useful, so they can detect in which location the theft is happening. So the second one is an ESP32 cam module. You can see captures an image of the current condition. So in my Telegram app, I'll show now. See, this is my Telegram app. I created an app for this, like I give a smart grid 59. So you can see my camera also taking a photo of that condition where the theft condition is happening. So that my camera also took the picture. This image is then shared to a Telegram bot configured on my mobile phone, I already shown. Additionally, an email is sent with an exact GPS location where the theft has been detected. Even I shown that also. This system helps officials like those from BESCOM to identify and act on power theft cases quickly and accurately. By deploying such technology, we can potentially save crores of rupees lost due to unauthorized electricity usage. For the hardware, I used here my ESP32 microcontroller for the processing, ESP32 camera model. You can see here, this is for image capturing, and I used LM317 toggle switches to stimulate the test condition. To give the test condition, I used this toggle switches, and then I used for Blynk IoT platform for live monitoring and altering. The entire system has been programmed using embedded C, and I used Arduino for this. So now I will show the coding part. So this is how we did our code. This is all in this it includes smart metering, power theft, over voltage, and cable fault detection. In this, how the photo is detecting, or in my part, the theft detected. This is the code for that. Theft detected with the Google location. So this is all about my topic. Thank you.
Let me explain two key safety features of my project: overvoltage protection and line fault detection. So these are the crucial for preventing electrical damage and ensuring a smart and stable power grid pass. Now let's move on to the line fault detection. Power line faults can cause major outages. To solve this, my system continuously monitors key electrical parameters like voltage, current, and load. If a fault is detected in any part of this line, the system immediately isolates the faulty section to avoid the further damage. So the system uses a GPS model and finds the exact location of the fault, and the data is processed by a ESP32 controller. So we get a notification by a Blynk app. So now I'm disconnecting the connection. After this, we get a notification in the Blynk app, like cable fault is detected in so and so time with a particular location where the cable fault is detected. And we get a mail also with the exact location. So now I got a notification related to the cable fault in the Gmail, so we can find the location, exact location where the fault is detected. Then using a Wi-Fi module, the fault details including location, type and time are sent directly to the BESCOM office. The staff can get this alert either on their Android app or through email. So this approach helps reduce power outage system, improves maintenance speed, and supports development of smarter, more reliable electrical grid. Now let us talk about overvoltage protection. Whenever there is a sudden increase in voltage beyond the safety limit, the system detects it immediately. Here's how it works. I am using a dipole switch in the circuit. When an overvoltage is sensed, the DP switch. So this prevents short circuit and protect home appliances from getting damaged. At the same time, the system sends instant alert through the Blynk app to inform the BESCOM office or user that an overvoltage event has occurred. It also shares the location and time of the fault. Email also related to the overvoltage and real-time location. This helps in tracking voltage patterns and planning preventive maintenance. Overall, it ensures better safety, real-time monitoring, and useful data analysis for the power department. Thank you.
In conclusion, my IoT-based smart energy management system provides an advanced and practical solutions for modern power challenges. It integrates smart metering for accurate energy usage tracking along with electricity theft detection, over voltage protection, and line fault detection. Real-time alerts through the Blynk app, GPS-based location tracking, and ESP32 cam image capture enable fast response and enhance grid security. This system promotes energy accountability, reduces power loss, and supports a smarter, safer, and more reliable electrical infrastructure. Thank you.
Thank you.